So, guys, let's start with the next topic in today's class, physics, thermal properties of matter. Okay, what and all is important. I think I'll take 2 to 3 classes to finish it off. The good thing here is, you already know thermodynamics when it comes to chemistry part. That basics will help you guys go through the remaining chapters in physics also. Okay, basics. Fine. Now, obviously, again, this is one of the most easiest chapters. I'll tell you what and all will come. Okay, there's a concept called as a relation between alpha, beta, and gamma. This will come, and there's something called as Newton's law of cooling. Focus on both these things more, and you'll be able to score marks. Okay. Apart from this, what else is there? All your 10th standard stuff where we talk about specific heat capacity, latent heat, all these things will get added up in first year. Apart from that, it's all simple. Okay. So to start off, what am I supposed to learn about? I'm supposed to learn about something called as heat. I mean, this class will be boring. Next class is where it gets interesting because end of the day, if you do not do the boring stuff, the interesting stuff actually becomes harder. That's the point. Fine. So heat is nothing but some sort of energy which flows from one place to another place, obviously through a medium. A medium is always required for heat to flow, for energy to get transferred. For example, the very famous handshake example. Okay, you feel the warmth or you feel the cold in some others in one of their hands. That is because heat is being transferred from one body to another body. This is the meaning of heat. Now, what is the meaning of temperature? Temperature is always the degree of hotness, meaning it is the measure of heat. Okay, measure of heat. Now, usually, how do we calculate temperature? Obviously, we know using a thermometer and all those things. Fine. Now, why do you think what is the reason for heat transfer? Obviously, again, to attain equilibrium is the complete concept, but since there's a temperature difference is what causes heat to transfer. Now, till when will the heat transfer? Till it attains equilibrium. Once the heat equilibrium is been attained, then the heat will stop getting transferred. That point where the equilibrium is attained, that has a special name called as thermal equilibrium. Thermal equilibrium. Okay, is the name of the is the name of the equilibrium which is attained through heat. That's the easier concept. Now, obviously, the next concept is important where we learn it as where we learn PV is equal to nRT, also called as ideal gas equation. This is what we've learned in previous classes, 100% yes. Where P is the pressure, V is the volume, okay? N is the number of moles being involved, R is the universal gas constant, T is the absolute temperature. Fine. This is what we know. Fine. Now, what happens here is you're supposed to understand that there's always relation between P and T asked multiple times. So pressure is directly proportional to temperature, which means more the temperature, more will be the pressure. That's what we know. Okay. So always keep this in mind. A numerical based on P is directly proportional to T can be asked, and 100% you should be able to answer. Along with this, you'll learn something called as absolute zero. Please remember this. Absolute zero is a term, okay, it's a term which is very useful, and in simple language, it is the absolute minimum temperature. Okay, it is the minimum temperature for what? For an ideal gas. Minimum temperature for an ideal gas. This is the meaning of absolute zero temperature. Sometimes they ask this as a definition. That's why I'm trying to give this, or else I usually give the value and move on. I think last year they had asked you guys to define absolute zero. A lot of people wrote the answer as the number and came. They didn't get marks. So this is the definition of it. Minimum temperature for an ideal gas. Now, what's the value? The value is nothing but minus 273.15 degrees Celsius. I don't think so. This is that difficult to remember because 273 is what we've learned during conversion of one thing to another thing. But what to remember here is this is not Kelvin, it is degrees Celsius. So just imagine how cold it is because there's a minus there. Okay. We will not be able to survive. Again, survival in the sense -3, -4 only is too cold. Fine. In that, and again, this is more ideal. Again, that's the reason it says an ideal gas. Minus 273 degree, 0.15 degrees Celsius. Understand? It is not at all Kelvin. So this is called as absolute zero. So from now onwards, if I'm talking about absolute zero, you're supposed to understand that the value is 273, but with a minus, and it is in degrees Celsius. Keep this in mind. Now, next is temperature scales. This is important. It can be numericals can be based on this for a 2 marker. Okay. Now, obviously, as we know, there are 3 kinds of temperature scales which we learned till now. The same thing will get repeated. One is called Celsius. One is called as Fahrenheit or Fahrenheit, whatever, and Kelvin. Okay. Now, Will they ask this as in terms of definition? 100% no. Everybody knows how it will be asked. It will be asked in terms of conversions. So how does the conversion go? Very simple. C by 100. Please mark this up, and very important it is. C by 100 is equal to F minus 32 by 180 is equal to K minus 273 divided by 100. Okay. Now in your colleges, they'll teach in a much direct way. The reason I'm trying to make it more complicated in this way is because, see, if the conversion is from Celsius to Kelvin, 100% C is equal to K minus 273, you'll be able to get the answer. Completely fine. But the problem here arises when you're trying to convert when you're trying to convert something in terms of Fahrenheit. Now in college, they'll again reduce the 32 and 180. I can't remember all these things because I'll tell you how I used to remember. The hint went like this: theta minus theta naught divided by n. N is the number of units on the scale. Theta 1 is theta is the theta TL, right? The highest temperature, and theta 0 is the lowest temperature. So on that scale, what's the higher temperature? On that scale, what's the lower temperature? I used to take, and that's how we're supposed to get the answer. That's the concept. Fine. If you're not taking the highest temperature, just take the representation of it. For example, in Celsius, how do you represent Celsius? It'll be C. And what's the lowest on the Celsius scale? Minus 0. Number of units is nothing but 100. So similarly, for Fahrenheit, it is F representation minus the lowest degree. I mean, the lowest number is 32 divided by how many units are there? 180 units are there. So this is how it works. Fine. But conversion is very, very, very important. That is why I'm trying to learn it in terms of by 100 by 100. Okay. So on Celsius scale as well as Kelvin scale, you'll find 100 units. On a Fahrenheit scale, you'll find 180 units. This is what we guys know. Now, let's try to convert only Celsius to Kelvin. In this case, if you see, C by 100 is equal to K minus 273 divided by 100. Automatically, this gets cancelled. C is equal to K minus 273. We will be able to come up with a relation then and there. Okay. But there's absolutely zero errors when you're trying to mug this up directly. The problem is, again, as I told you, when you're trying to convert in terms of Fahrenheit. Okay. So instead of learning two things at the same time, learn one relation and it can be applied in all number of in all the cases. So let's say the question says we're trying to convert something from Celsius to Fahrenheit. So it goes like this: C by 100 is equal to F minus 32 divided by 180. Since you guys obviously know math, cut off the 0 and the 0. 2 times 5, 2 times 9. Now crisscross. Now, it obviously becomes much more simpler. So this becomes, if you crisscross the 9, it becomes 9 by 5 into C is equal to F minus 32. That's the concept. Fine. This you will be able to derive. But if you only remember 9 by 5 C is equal to F minus 32, there's nothing wrong. But my question is, what if you write 5 by 9 instead of 9 by 5? It becomes a complete useless thing for the answer or for the concept which is so simple. So what I would suggest you guys to do is try to focus on this more compared to the easier ones. I'll give an example with an actual number right now. So let's say it says convert, all these things are 2 markers. Convert 20 degrees Celsius on Fahrenheit scale. Now what will you do? Don't follow this 9 by 5 shit and all. Please don't do it. Okay. So by chance, let's say you forgot. They're telling C to F here, Celsius to Fahrenheit. I'll tell you how I would do. I would prepare then and there. If you don't know how to mug the formula also, completely fine. I'll give you a trick right now. See, the conversion is from my focus is from C to F. C we represent as C itself minus what is the least number on a Celsius scale? 0 divided by how many units are there? 100 is equal to F is a representation minus 32 is the least number on Fahrenheit scale divided by 180. I got the answer right now. But the good thing here is, okay, C minus 0 is nothing but C, 100, F minus 32 by 180. But the question right now says convert 20 degrees Celsius, which means in this question, I know the value of C. I'll write 20 by 100 is equal to F minus 32 divided by 180, 5 times. Okay, 5 times 1, 5 times, how much? 1's are, sorry, 3's are, and 3, 6. So 36 is equal to F minus 32. F is equal to 32 plus 36. This is my answer, which is nothing but 68. 68 degree Fahrenheit. You're supposed to write the degree there. Okay, 68 degree Fahrenheit. That's my answer. Okay, so this is the answer. So make sure that you guys, if you do not know, you convert it. So let's say that I give the same question in terms of Kelvin. Kelvin. So what do you write? C representation minus 0 divided by 100. Why did I write 180? It's 100. is equal to, it says Kelvin. Kelvin is K minus 273 is the lowest number divided by 100. 100 gets cancelled. So 20 is the, okay, 20 is given to me. 20 minus 0 is equal to K minus 273. 20 plus 273 gives me K. This is the answer. 293 Kelvin will be the conversion of temperatures. Simple. So if you observe one thing properly, I have not put on degree symbol here. No degrees when it comes to Kelvin. It's directly Kelvin. Okay, for Fahrenheit or Celsius, you're supposed to put degree. Fine. This leads us to the next concept of thermal expansion. Anything you heat tends to expand. Anything you cool tends to compress. This is how nature works. Okay. So we're gonna focus only on thermal expansion, which means only based on heat. Okay, only based on heat. Now, what's gonna happen? Let's say there is again, what and all applications are there when it comes to thermal expansion? One is increase in length. Okay, all these things will be there. One is increase in terms of area. One more is increase in terms of volume. How to remember? I'll tell you. Meter square, meter cube. All the three things will expand when heat is given to them. Okay, everything will expand. Now, how do you? Okay, fine. So basically, whenever length increases, okay, that increase in length. So let's say you start heating one rod of length L. Okay. After heating, it becomes L plus delta L. I'll explain how. So let's say the rod was 10 meters. After heating, it became 10.5 meters. So what's the difference? The difference was equal to 0.5 meters. So the difference in physics is always represented by delta. So delta is equal to 0.5. What was 0.5 meters? Again, some sort of length itself. Therefore, delta L is nothing but increase or decrease in length. Expansion always means increase. Therefore, I write delta is nothing but increase in length. Okay, remember this. So when you heat up a rod of length L, it tends to become L plus delta L, where delta L is nothing but the increase in the length of the rod. Why? Due to heat. Similarly, if I write A plus delta A, it means the area also increased. What's the increase in the area? Delta A. Similarly, the last one is volume, V plus delta V. What's the increase in volume? Delta V. That's how things work. Okay. Now, we're supposed to learn something called as alpha, beta, and gamma is what I told you initially when starting the chapter. Now, what's the meaning of alpha? What's the meaning of beta and gamma? We'll be learning right now. So there's something called as coefficient of linear expansion. I'll repeat that. Coefficient of alpha's name. Coefficient of linear expansion. Linear expansion. Okay. Now, how does this work? Very simple. So alpha is actually given by the formula, which goes like this. Increase in length. Guys, always understand, if you follow the pattern here, length came first, area came next, and volume came the last. Similarly, alpha, beta, and gamma. So whenever I'm using the constant called as alpha, I'm always referring to some sort of length. Whenever I'm using beta, I'm always referring to some sort of area. Whenever I'm using gamma, I'm always referring to some sort of volume. This is how it should work. Okay. So alpha, length, beta, area, volume is gamma. That's how things work. Now, alpha is nothing but increase in length. So that length divided by initial length. Initial length. I'll extend easily also, but just like this. Into rise in temperature. Rise in temperature. Very simple, guys. Focus here. You write alpha. Increase in length is nothing but delta L. Initial length is nothing but L into rise in temperature is always there in the denominator. Correct. So 1 by delta T. Why delta? Rise in temperature. So initially it was, let's say, 10 degree. It became 15 degree. My concept is it started expanding only after I increased. How much was the increase? 5 degrees Celsius. So I'm more focused on the delta part and not the regular part. Now what happens here is, in your colleges they'll teach, let's make the deltas one side. So it becomes 1 by L is equal to delta L by delta T. So this is the actual explanation they give in college. They want all the deltas to be in one side. Similarly, let's talk about beta. Beta was nothing but, I told you, area. So common sense is increase in length becomes increase in area. How do you represent increase in area? Delta A divided by, what's the initial area? A into 1 by delta T. Similarly, okay, but how do they teach in college? They write 1 by A into delta A by delta T. Both are correct, guys. There's absolutely nothing wrong. Gamma is nothing but volume. So it will become delta V by V, into 1 by delta T. College, what do? They write 1 by V separately, delta V by delta T. They get the answer. That's all. Fine. So whenever there's an increase in length, alpha, area, it's beta, and gamma is in terms of volume. Okay. Simple. Now what they ask you, once you learned all these three things, Again, what is this? This is called as coefficient of linear expansion. Similarly, I didn't give the name for beta and gamma, sorry. Beta will be called as coefficient of superficial expansion or area expansion. Okay, coefficient of superficial. F-I-C-I-A-L. Okay, this is volume. Okay, so it will be called as cubical. Coefficient of linear expansion, coefficient of superficial expansion, then coefficient of cubical expansion. That's how things work. Okay. Now, they'll ask you, once you learn both of them, they'll be like, give us the relation between alpha and beta. They'll ask this. Or derive the relation. Derive the relation between alpha and beta. Now, how do you go? And always understand one thing. Alpha always represents, talks about length. Beta is about area. Keep this in mind. Now, how do you start off? Regular formula. Don't we know that area of, let's say, okay, we'll take a small rectangular sheet. Rectangular sheet is where we're trying to get our answers on. Area of a rectangle is given by length into breadth. Agree? Now, let's assume that delta t, okay, fine. Obviously, area is equal to length into breadth of a what sheet? Of a rectangular sheet. Now, what I'm going to do here is, I'll start increasing the length. Okay, I'll start increasing the length. Oh, sorry. Increasing the temperature, my bad. Why am I telling length? Because expansion is required. Expansion happens only if you increase in temperature. Fine. Now, what's going to happen? Once you increase in temperature, initially the temperature was T. After increasing the temperature, it becomes T plus delta T. Agree? Initially, it was T. Once you increase, it becomes T plus delta T. So, think for a second. A is equal to L into B. Don't you think when temperature increases, everything increases, area also increases, length also increases, and breadth also increases? So don't you think after increasing temperature, A becomes A plus delta A, agree, is equal to L becomes L plus delta L. I'll put it into as it is. B becomes B plus delta B. This happened when? Only after increase in temperature. Increase in temperature took place. And that's when we see this. Now, if you, okay. Now what happened? We will get stuck here. I'll do some working on the right-hand side here based on whatever I know using this specific answer. So alpha is equal to 1 by L into, 1 by L into delta L into delta, delta L by delta T. Now see what's going to happen. I'll write that. Alpha is equal to 1 by L into delta L by delta T. I should have used lowercase, but I used caps. No problem. No worries. Fine. Now what I'm going to do, I'll try to find the answer for, okay, I'll try to find the answer. Okay, before that, yeah, I'll try to find the answer for delta L. Delta L is where here. Shift everything on the denominator to the left-hand side. So can I tell delta L is equal to alpha L delta T? Agree? Alpha L delta T is the answer. Correct? Now, obviously, this is what I know the answer for delta L. Similarly, for delta A and delta whatever, I'll be able to find it. Fine. Now see here, when you're trying to assume here, no, we will assume the increase in temperature or delta T to be 1 Kelvin. To be how much? 1 Kelvin. I'm assuming the delta T to be 1 Kelvin. So if I substitute here, can I tell delta L is equal to alpha L? Agree? Because delta T is how much? 1 Kelvin. I'm assuming this. This is an assumption. Delta T is equal to 1 Kelvin. Delta L became alpha into L. Now see what I'm going to do. Ignore the left-hand side. Only focus on the right-hand side. I'll write L as it is. Instead of me writing delta L, I have an answer right now. Alpha L, I wrote. I'll open brackets. B as it is, plus. If delta L is equal to alpha L, delta B will be equal to alpha B. Alpha B, I wrote. Okay, I'll repeat this. So how am I getting this delta L? Delta L I was not comfortable with. So I changed it in terms of regular things. Using the previous slide, I got this answer. Now I assume that delta T is equal to 1 Kelvin to make my answers easy. And I get the answer as delta L. Now see, I have two brackets on the right hand side. I'm ignoring the left hand side completely. In the first bracket, I can see L being repeated twice, which means I'll take common. After taking L common, the answer inside the bracket becomes 1 plus alpha. Agree? Dot. In the second bracket, I can see B common. I'll take B common. Again, it becomes 1 plus alpha. I hope you guys understood this. So in both the brackets, whatever was common, I took it outside. Now, since on my right-hand side, everything is, the there are into between it, I'll regularly multiply. So it becomes is equal to L into B into 1 plus alpha the whole square. L into B into 1 plus alpha the whole square. Okay. Now, this is what I got. I'll expand the right hand side. L into B as it is. A plus B the whole square. A square plus B square plus 2AB, 2 alpha. This is what I've got. Fine. Now, the good thing here is, I mean, you should be grateful for this, that you actually know the answer. Fine. Now, obviously, on the left-hand side, what can be seen? I had what? I had A plus delta A. Again, got it? So I had A plus delta A. I'll write it. Left-hand side, I had A plus. Okay. First of all, how do we name the left-hand side? Increase in area, correct? We name the left-hand side as increase in area. 1 minute. A plus delta A is this answer. Okay. Now, think for a second. Think for a second. A plus delta A, I know. If I ask you, how do we find only the value of delta A? I don't know. Because, I don't know in terms of numericals, but if you look at this as an equation, okay, delta A is on the left-hand side. Keep the delta A as it is. Whatever is on the right-hand side, write it as it is. 1 plus alpha square plus 2 alpha as it is. The plus A comes to the right-hand side, becomes minus A. Why am I doing it? I want the answer only for delta A. What is the English meaning of delta A? Increase in area. Okay. Increase in area. So what did I do till now? I wrote increase in temperature, assumed it to be 1 Kelvin. I did delta L, delta B, I was not comfortable. Like converted in terms of alpha L, alpha B, got it. I took common. I got whatever plus alpha the whole square. I expanded it. I told you find the value of delta A. So keep the delta A as it is. Send the A to the other side. It became minus A. Now, again, continue. Delta A as it is. LB into copy 1 plus alpha square plus 2 alpha as it is minus, fortunately, we know the answer for A. First equation, what? L into B. I'll write LB. Okay, I'll write L into B. Now, again, on my right-hand side, I have two parts. And in both the parts, obviously, what can you take common? You can take LB as common. Okay, you can take LB as common. So, delta A is equal to, if you take LB common, careful, in the first thing, what and all is remaining? 1 plus alpha square plus 2 alpha remains. Minus 1 remains. Plus 1 minus 1 got cancelled. Okay. So regular math I'm trying to do. Then delta A becomes LB as it is into alpha square plus 2 alpha. Alpha square plus 2 alpha. Okay. Now, thank God I got this answer. Okay. Thank God I got this answer. Now, obviously, if you see, alpha is the coefficient. So assume, okay, I'll give an example. Alpha is the coefficient. So this alpha will be very small. Assume 001. If alpha only is so small, alpha square becomes even more smaller. Correct? It will become 0.00001, which is absolutely zero change. So since alpha is small, alpha square will even be smaller, which means alpha square can be neglected. Why? Of its very small value. It won't make a difference. For example, if you grow 0.0001 taller, will it make a difference? 100% no. So alpha square can be neglected. So delta A after neglecting becomes LB into 2 alpha. Okay. LB into 2 alpha. Now, I know the answer for delta A. But the main question says, what is the answer for, what is the relation between beta and alpha? Now, see, I have alpha here. Now, see what I'm going to do. Beta, we know the answer. How? We learned the coefficient, no superficial. Here, it says 1 by A into delta A by delta T. Beta was given by the formula 1 by A into delta A by delta T. Okay. Delta T in this case was 1. Okay. So keep this 1 as it is. Delta A's value is what? I found right now. LB into 2 alpha. Left hand denominator, what's the value of area? L into B. Delta T is what? 1. So left hand side is beta. LB gets cancelled. I get the answer as beta is equal to 2 alpha. Beta is equal to 2 alpha. Simple. Okay. I'll repeat it. It seems to be long, but it's very simple. We start with area, rectangular, length into breadth. Increase in temperature, length also becomes more, breadth also becomes more. How much more? Delta L, delta L. Then I told you I'm supposed to find the value of delta L. How? Using that alpha. Using alpha. You keep the delta L, but delta T was a problem. You assume it to be 1. Now what happened? On the right hand side, everything was in terms of into. So you multiply them. You get A plus B the whole square. You apply. This is the answer. Left hand side was A plus delta A. You won't stop here. I only want the answer for delta A. So keep the delta A there itself. Send the A to the other side. Regular math. Area was equal to length into breadth. We started. We took common. Everything got cancelled. Then I get delta A is equal to whatever. But I realized that alpha only is a very small value. Alpha square will be even more small value. So I neglect the value of alpha square. So delta A becomes LB into 2 alpha. I don't stop here. But the main question said, what's the relation between beta and alpha? So you go one step ahead. You write the formula for beta. Beta is equal to 1 by A into delta A by delta T. Delta A's formula is LB into 2 alpha. You got A's value is LB. We got it. Gets cancelled. Delta T was anyways 1. Don't forget this, sir. Delta T is always 1 in this case, 1 Kelvin. So beta is equal to 2 alpha. Simple. Okay. So now you guys try what's the relation between gamma and beta. Okay. Gamma and beta. In the next class, we will solve this. Fine.